I would like to invite Rowan on the stage. He represents Cenosco. He is AIMS expert, chartered engineer, integrity and corrosion specialist, and let me tell you, a fantastic trainer. I have attended a training at Mangalore, and excellent trainer. Please, Rowan.
Okay. Hi, folks. Good morning. It's amazing to see such a great turnout today. So the topic that I'll be presenting today is switching from time-based inspections to risk-based inspections. I think this will sit quite well with the two speeches that we had, the one from our esteemed chief guest and a keynote presentation from Rahul. So yeah, let's go through that. So just waiting for the slides to come up, but in the meantime, no, it's the other one.
The first one.
Yeah. So the topic that I wanted to cover is not this one. We're just trying to load up, so just give a few minutes. So the topic I wanted to cover is switching from time-based inspections to risk-based inspection. What are the considerations? What are the benefits? Or maybe is it even really required? So let's look into it holistically. So my name is Rowan Vadikanathan, and I think Samir introduced myself. So I'm based in the Netherlands, in Den Haag. I'm a materials and corrosion engineer by background. I've been working with Cenosco for the last couple of years. So with Cenosco, we have worked with global leaders in the oil and gas, chemical, and petrochemical market for a number of years. So as part of this presentation, what we have done as well is that we have brought in our learnings and findings. So we have sat with some of these customers for a number of weeks, months, understand how they operate and how we as a digital software solution service provider can add value to the day-to-day operations and so on. Okay, so this is a brief agenda. So just quickly take you through this. So the plan for the next 20-30 minutes is to look into the different types of approaches when it comes to managing your inspection activities, primarily your static pressure equipment. So we'll be looking at the two primary inspection-based approaches, time-based inspections, and we'll also be looking at RBIs, as it's usually called, which is abbreviated as risk-based inspection approaches. And we'll be putting both time-based approach and risk-based approach right next to each other, picking up few key metrics and comparing how these approaches perform against each other. And finally, some key takeaways for everybody to take on board. I'm pretty sure this will be quite interesting and quite value-adding as well. So when it comes to inspections, so we did talk about inspection activities being carried out within our sites. So the usual common approaches that we have within the current scenario is having a time-based approach, which usually focuses on performing inspections at regular fixed intervals. So time-based inspections does not focus too much on where your threats are. It's not very focused at specific locations where your threats are and so on. On the contrary, risk-based inspections are primarily inspection activities planned, managed, and executed in accordance to the risk profile of your equipment. If your equipment isn't being serviced for a number of years, it will go through a specific life cycle. It'll be exposed to a number of fluids and so on. So as time and age passes, we can expect degradation to occur. But the focus here is to clearly understand where we can expect the degradation to occur so that we can put our efforts in identifying where these findings from inspections can typically be identified. So just a bit of a background with regards to time-based approaches. How did these time-based approaches come into place? If we are running an asset, we inherently have a responsibility to maintain the asset. We don't want to put the people that is working in our asset under risk. Of course, we want to ensure productivity is maximized. So, of course, these time-based approaches typically originated because there is legal requirements. Your regulator typically forces you to inspect critical equipment every 4 years, 5 years, and so on, maybe based on maintenance practices, site experiences. You have very knowledgeable, experienced personnel working within your sites. So based on site experience as well, it's easy to adopt a time-based approach, manage inspections at fixed intervals, and identify the actions that needs to be carried out. But what really happens during outages, shutdowns, is usually with the fixed time interval approach, you're pretty much focusing on everything. You're trying to inspect all your critical equipment. If there are findings from inspections, you want to remediate those locations straight away. So what it really results is, it typically results in increase in your plant downtime. And since it's not very focused on risk or locations where your leaks can occur, so there is a potential for unplanned downtimes as well, so what we call as critical leaks. And since there's no systemized or structured way of managing time-based inspection approaches, usually what it could result in surprises, unplanned leaks, which could result in downtimes and so on. Sorry, just skipped a slide there. Okay. On the other hand, RBIs, risk-based inspections, it typically prioritizes inspections based on risks. So you typically identify equipment, understand the criticality of the equipment, schedule inspections in accordance to its risk. So the focus with RBI approaches or risk-based inspection approaches is to focus on high critical equipment or assets and limit your focus on low critical assets. You don't want to be inspecting your low critical assets every 3 years, 4 years, when in reality, the criticality from your specific assets is typically low. It typically has no impact on asset, environment, community, or people consequences. And of course, RBIs, with an RBI approach, plants adopting RBI approach have managed to increase the plant availability. So it has resulted in shorter plant turnarounds, better predict and plan for repairs. And there's a drive mostly for on-stream inspections, try to perform inspections on the run rather than taking equipment out of service and perform inspections during outages. Okay, so what this does is that it gives you good control with regards to your asset threats. You have to perform a systematic approach. You really have to understand your risks, your threats, and you typically schedule inspection activities accordingly. So let's dive a bit deeper with regards to RBI's risk-based inspection approaches, because we usually get the questions from our customers or prospects. Yes, we would like to go down through the RBI approach. How do we start? Where do we start? So here are some international standards guidelines that is already available for us. So these are typical aspects that we can already refer to. API, as you all should be aware of, API 580 highlights the concepts of your RBI. 581 is more like a very quantitative methodology that goes into a bit more detail and allows an RBI assessment to be performed. We talked about offshore industries, so DNV RP G101 is a guideline document for RBIs on offshore static equipment. REMAP, EMUA are European guidelines with regards to implementing and executing an effective RBI. And of course, there are other standards or guidelines, API 571, API 510, 570, 653, 576. So these standards or guidelines could be used in conjunction with your RBI guidelines. So something for us to keep aware of. Let's go through the workflow. What does an RBI mean? So we said time-based inspections. We inspect equipment at fixed intervals. RBI, how do we inspect based on criticality or risk? So with regards to RBI inspections, one of the key steps to start off with is all about collecting data. So we mentioned this morning that there is data everywhere. So it's good to collect that data, have it in one place, make a data-driven decision before you even start performing RBIs. So the first step before you commence RBIs is to identify critical data that supports your RBI assessment, have them in one place, make a data-driven decision before you could jump on to the RBI process. The risk analysis process typically looks into the consequence of failure. What is the severity if an equipment leaks? Does it cause production impacts? Does it cause harm to your people that is working in your plant? Does it cause environmental issues? All those aspects have to be looked into. And as part of the risk analysis process, we also look into the probability of your failure. How likely can your equipment fail? In order to understand how likely an equipment can fail, we need to understand what all threats the equipment is exposed to. So we typically have to understand your process conditions, your operating conditions, and of course your history as well. What is available with regards to your history of your equipment. We should have done some level of inspections in the past. So have we seen issues? Have we seen concerns? All that should be collated and made available in one place so that that decision could be made with regards to assessing your consequences and your probability. And eventually, once the risk analysis process is complete, we then risk rank our equipment. We identify the criticalities based on probabilities, consequences. Then we come up with a specific plan of inspections. And the inspection plan is usually prioritized based on risk. Once we have an inspection plan, it's all about executing the inspections. And then on the back of the inspection, if there are actions, repair actions, mitigation actions that needs to be carried out, those can be executed. And eventually, since we have new inspection results now, we just have to revisit the RBI, update the RBI, and plan inspections in accordance to your risk. So the risk analysis process there will typically identify your risk and also allows you or gives you intervals and next inspection dates in accordance to your risks. Okay. However, RBI, there are different types of approaches: qualitative, quantitative, semi-quantitative, is somewhere in between. So as you could see from the chart on the left, so a qualitative analysis usually needs low details, so you can easily onboard to a qualitative approach. Quantitative is quite extensive, quite rigorous. Statistical modelings are typically applied to understand your risk profiles, and based on that, you would identify your intervals and next inspection dates accordingly as well. And semi-quantitative is somewhere in between. It's not data intensive, but at the same time, it's not very rigorous as well when it comes to executing a semi-quantitative RBI approach. So these are something that we all should be aware of, because if you're stepping down towards the RBI approach, it'll be good for us to make a decision on which approach should we adopt. And there's no one-size-fits-all in this case, because it's vital to consider how our business operates. For example, if our business or if our asset has got a life of another 3 years or 5 years, then there is not a lot of justification to invest on an RBI approach. So it's good to understand how our business operates. So it's good to understand our risk tolerance as a business. What is the data available? So we talked about data availability, but it's probably siloed. It's not very structured. It's not available in one place. All that evaluation has to be done. And of course, time and resources. Stepping on to the RBI journey could be labor intensive when you start off with. So that has to be taken into account, because labor intensive typically adds on to your cost accordingly as well. So when you put qualitative approaches and quantitative approaches right next to each other, as you could see, qualitative approach typically stands out when it comes to data requirement, effort required, and the complexity. It's easy to onboard onto a qualitative approach because it takes into account people's judgment and expert opinion and so on. However, the downside with the qualitative approach is it is not very accurate, and probably due to the lack of accuracy, it cannot be applied to critical equipments and so on. On the other side, quantitative really stands out when it comes to accuracy and ability to be applied to critical equipment. But of course, it is intensive when it comes to preparations, so considerable effort is required, and of course, it could be complex depending upon your business requirements as well. Okay, so this is typically a summary with regards to how RBI could be executed, or how are the different approaches in RBI available as of today. But let's compare time-based inspection approaches and risk-based inspection approaches, because ideally we really want to get away from time-based inspection approaches and move towards risk-based inspection approaches. Time-based inspection approaches are quite repetitive, quite specified at fixed intervals, so maybe for non-critical equipment it's not really efficient. So when you put time-based approaches and risk-based inspection approaches right next to each other, we have highlighted a few key metrics and how these approaches perform against each other. So time-based inspection approaches, usually implementing and updating is quite quick, so it really stands out. RBI really needs investment with regards to implementing an RBI program and getting it updated on a regular interval. So it is a continuous improvement process. It needs investment with regards to updating RBIs on a regular basis. However, if you look into other metrics, which we call the value cases, adaptability to risk, increasing plant availability, reducing inefficiencies, or long-term impact. So risk-based inspection approaches clearly stand out in such cases because time-based, since it's based on fixed intervals, it's usually not adaptable to risk. It doesn't allow you the opportunity to increase plant availability. And of course, there's a lot of inefficiencies because you're pretty much focusing on equipment that are really not critical enough. And also, from a long-term impact, it doesn't provide you ROIs or cost savings accordingly. So we have broken this down. We have worked with a number of operators, oil and gas, chemicals, petrochemical. We have worked with their data. We've looked into a high-level cost associated with regards to inspecting or adopting an RBI approach. And usually, what we see as a trend is that people see the initial effort to be extremely higher when it comes to RBI approaches, and hence there's always a bit of reluctance to take that step forward. Time-based approaches are quite easy to be set up. Initial and execution effort is fairly lower, so sites tend to still adopt such approaches. However, what we should actually be doing is that we should be pulling up the value cases. Yes, the implementation and the effort required initially for an RBI could be higher, and we shouldn't be making decisions only based on that. What is my value in year one? What is my long-term value? That has to be looked into. And we have worked with a number of operators, and we have come up with key figures out here. So when it comes to adaptability to risk, increasing plant availability, reducing inefficiencies, and long-term impact, RBI approaches clearly stand out. Increasing plant availability, a site adopting RBI approaches can increase your plant availability to a maximum of 25%. So what that means is that you're pretty much optimizing your plant downtime. You just want to focus your high risky areas, high critical locations or equipment during plant downtime. At the same time, you are trying to avoid non-critical leaks and avoid unplanned downtime as well. Okay, so this value proposition should be looked together along with the implementation effort. So decisions should not only be made based on the effort required for implementing and evergreening your RBIs accordingly. Okay, so let's look into the challenges with regards to RBI adoption and how these challenges could be mitigated. So as we have seen so far, one of the key challenge is your first step with regards to data collections, implementing and executing an RBI approach. So how could these challenges be mitigated? So of course, data availability is a key challenge out here. So as an organization, we should be leveraging on technologies. So technology typically allows your data to be structured. You can collect your data quite structurally. At the same time, you can use data from multiple aspects. So we talked about data silos earlier. So different teams have their own systems. They're managing their own databases separately. So since this way of siloed operation is really not effective when it comes to scaling up, technologies that could bring all these data together in one place, allowing us to make data-driven decisions. So those are typical key aspects when it comes to mitigations. And of course, updating your RBIs. Once we have new results, we should be updating our RBIs. Evergreening is a common challenge. Yes, we have implemented RBIs, but updating RBIs on a constant basis is really not effective or efficient. That is the common feedback that we get. And again, leveraging technology such as Cenosco's products will provide automations in certain cases. You have inspection results in one place. Based on that, you'll be able to identify your corrosion rates, your remnant life. You can easily incorporate that to an RBI and identify your results or outcomes quite effectively. However, when you zoom out and look at a much more wider issue, not just the issues with regards to implementing an RBI, but of course a much more wider issue. If we as organizations, if we are typically transitioning from a time-based approach to a risk-based approach, it needs a cultural change. It needs a mindset change. And it's not just inspection or integrity team's problem. It's a much more wider problem. So as different disciplines, different departments have to be involved, and an investment into an RBI is not just an integrity related issue. It is a much more wider approach. And of course, with regards to cultural change, that should also be driven with regards to data-driven decisions. There's so much data available. How could we effectively utilize this data and get value from our data? So it is a much more wider approach. And a common problem across the industry, knowledge and skills with regards to adopting an effective RBI program. So again, it is a much more wider issue. How could we effectively mitigate it? Trainings, collaborations with partners, multidiscipline departments, teams have to be educated to understand or highlight the benefits of an RBI. Global leaders, Shell, BP, Chevron, are trying to set up bases in India. They're trying to enhance their technical competencies and resources. So it is something that we have to take a step back and think, how could we effectively train our teams? How do we ensure that our teams are quite skillful to ensure this risk-based approach is continuously being delivered so that we have more control with regards to our assets and threats. Okay, so overall, the challenges, data availability, evergreening, much more wider challenges such as cultural change, knowledge and skills, and some of the key mitigations are using technologies, make data-driven decisions, collaborate with multiple disciplines, trainings, and so on. Okay, so what are the key takeaway points here? Are we totally disregarding time-based inspections? Are we just throwing it out of the window? Definitely not. So there will be cases where time-based inspection approaches could be suitable. So especially if you have low critical items, you don't want to be investing RBI approaches on low critical items. You can leave them at longer intervals for low critical items where your environment is quite predictable. And in certain cases, certain equipment, certain systems are subject to regulatory requirements. And if the regulatory requirements are already strict enough, you don't want to be going down the RBI route to identify your threats and inspection actions accordingly. And of course, like I said earlier, asset life. If your asset life is minimal or low, If your asset life is another 3 years, there's not much justification to onboard to an RBI approach and deliver value for your companies. However, in all other cases, RBI is extremely beneficial, especially when you're dealing with complex and high critical assets, oil and gas, chemical, petrochemical. It provides the user, us, a very good understanding with the asset threats and allows us control to execute and mitigate these actions. In order to mitigate actions or in order to perform control actions, we need to understand the threats. A risk-based approach gives us a good understanding on where the threats are, which locations, and how these threats could manifest over the years. However, a key blocker, like I said earlier, is the effort required for implementing an RBI. Effort required, taking that first step is quite huge, and that is usually a blocker for companies to onboard to the RBI process. But we should be looking at a much more wider picture. We should be zooming out, looking at our return on investments in the longer run. So decision should not only be made based on short-term implementation efforts and resources required. And of course, how could we enhance RBI approaches? Yes, RBIs could be done in Excel sheets, Word files, but is it really scalable? Probably not. You really want to count on technologies. You want to leverage technologies. You want to ensure all your data is available in one place. You don't want your teams to be digging out data from each discipline on a regular basis. Leveraging technologies and using all the data from different resources, displaying it in one place, using that to perform your RBIs will definitely be extremely helpful in the longer run. Okay, with that, I will conclude my speech. Thank you so much, everybody, for your patience. If there are any questions, I can answer.
Yes, Mr. Raven, very nice to hear about the RBI-based inspection. But in oil and gas industry of India, we would like to refer first what statutory norms have been driven. Nowadays, there is amendment in PNGRB notification in 2023. In line with that, the specific standards have been prescribed in OSD. So, if you refer to the OSD standards, the specific mechanism of asset integrity and inspection is been given. And to accommodate that into the RBI based inspection, how we are going to manage it?
So to be honest, I'm not really familiar with the India standard that you have highlighted, but I can tell something from my experience as well. Cenosco, based in the Netherlands, we work with global leaders. So Scandinavian countries, Norway, Sweden, have similar approaches. So the regulator forces them to perform inspections at specified intervals. But what companies have done is that they've used an RBI-based approach based on industry standards. They've gone back to the regulator. They've pushed it back to the regulator. Hey, this is what we have done. Could you please have a look into this? We are open for comments. We are open to take your comments. And the regulators have actually spent time with the operators, and with that, they have adopted RBIs on critical assets. So this is typically a real-life use case in our scenario, in our experience. Like I said earlier, like Rahul mentioned earlier, we closely work with MRPL. With MRPL, we are slowly onboarding to the RBI approaches, but to answer your questions, I should really understand what the Indian directive typically states or highlights. So hopefully have given you some thoughts or some
Oh, very nice, very nice. We'll discuss this later on also, no problem. Okay. So myself, Jayesh Patil, I am from Indian Oil Adani Ventures Limited. We are from the midstream industry. Okay. And basically, now the implementation of these statutory norms according to the PNGRB, we are really typically facing this issue to convince the regulatory affairs. Okay, okay.
We can have a chat later, sir. We can also share some experience with our Scandinavian customers as well.
Thank you.
Thanks a lot, Rohan. Fantastic detailed presentation. On my back side, there are two logos. One is Cenosco, another is Hexagon, because we are exclusive partners of Cenosco, and we are a premium partner of Hexagon. Hexagon for all their CAD products, as well as enterprise asset management, Hexagon EAM product. So I would like to call upon stage Mr. Dhananjay Kadlabal, and he will be talking about, he is basically a senior solution consultant at Hexagon, and he will be talking about smart digital reality, SDX, with Cenosco and Hexagon. Please.
Morning all. My name is Dhananjay and I'm here from the Hexagon, representing Hexagon Asset Lifecycle Intelligence Division. Hexagon is a Swedish-based company. The Asset Lifecycle Intelligence Division is one of the 9 divisions that Hexagon has. This is more related to the oil and gas, petchems, chemical industries where we support or we have solutions across all the phases of the project, so from planning till cybersecurity. Our motto is construct and operate more profitable, safe, and sustainable industrial facilities. So we have been hearing a lot about data from Rahul, from Rowan. That's where we also come into place, where we can put your data, digitize it, automate it wherever it is possible to make the broader picture of having a much more sustainable planet. So in order to achieve this, we have come up with a vision called the smart digital reality, where the data that is getting created in the new assets that you are building or the existing assets which already have a lot of data in them, they both are getting captured and are being transferred to the digital backbone that we have made it, called as Hexagon SDX. The physical activities are getting captured, helps the key stakeholders to visualize and analyze and define certain actions, keeping in mind to have the safety always at the top priority, increasing the quality, productivity, and efficiency of the industrial facility. So going one step down further, having the 4 pillars of safety, quality, efficiency, and productivity as the foundations for it, we have broadly defined into digital projects and digital assets. So digital projects is where your DECs, your EPCs, your EPCMs play a vital role there. Planning your project, designing your project, executing your project based on procurement, fabrications, constructions, etc. Once that is done, that is handed over to the owner-operators, mainly to operate, maintain, and produce oil if it is oil and gas, have petchems when it's a petchem plant, so on and so forth. So in order to have an integration between the various phases of this particular asset's life cycle, from planning till the secure phase, there is a digital backbone along with a lot of data services and application services that stitch together the various phases of your asset and gives you one single pane of glass where you will be able to view all the data instead of opening 10, 12 different applications on one single platform. And then that helps you in taking certain decisions that are required at the correct time. Rather than being a reactive person, we can be a more predictive persons and then take those decisions in a very timely manner. So the digital backbone that we speak about is basically Hexagon SDX, smart digital anything and everything. So X is the mathematical variable X that we put in. So whatever you would want to call it, we can call that as X. So we call it primarily the digital backbone for your facility. So what does Hexagon SDX do? So you can browse your information, any information, starting from your PNIDs to your 3D models, to your purchase orders, to your construction progress, the historian data that you would want to look at it, the sensor data that you would want to have a look at it. So those can be viewed inside. It gives you a very good insight view or dashboards, to be very specific on that. You can have your visualizations and comments, markups done within the system. You don't have to wait for a PDF writer license to be available with you to do certain comments and send it back to your subcontractor. SDX will help you do that. We can search based on a tag. So primarily, SDX is a a web page that is there, which runs on all the major web browsers that are available in the market. So it's a zero footprint. You don't need to install anything on your laptop. It can be viewed through your phone as well. It's also there in the SaaS offering here. So any data that is being built during the projects phase or the digital projects phase, your asset is still under designing or under construction. So it becomes a part of your project digital twin. The same project digital twin can be leveraged during the operation and maintenance phase, since the data is already available with you in the same platform, can be well utilized during the operations and maintenance phase of it. So one digital twin for both project as well as for the operations. Further drilling deep inside SDX, so this is the info map or the tag navigations that you can look at. So I've just searched for a tag, and wherever the tag is mentioned, may it be in your process data sheets, may it be in your vendor data sheets, or even the sensors that are attached to that particular tag, everything gets collated, contextualized in a way that helps you in taking a decision better. A small example of how it would look like is basically we have integrated with multiple different solutions here. So SDX is giving you the tag details. J5 is the operations management piece that Hexagon offers. So you can see the work permits and the logbooks in the same screen. You will also be able to see the maintenance activity, the work orders, or the notifications from Hexagon's EAM. And then there is a historian data from OSI Pi that can also be viewed in the same single pane of glass. So if there is any anomaly that is coming up in the operations phase, you will be able to understand what has happened, at what point has it happened, how do I go ahead and tackle this particular problem. Not just that, it also handles the entire document management systems for you. So if you would want to have any IFC, IFR, IFD, ISO drawings that are to be issued, are to be signed off, are to be revised, or if you would want to retire anything. So every possibility of a document management system can be handled again within the same suite of solutions. It also provides you a simple understanding of what was changed between the two revisions here. So this is a small example where you can see an older revision of the same PNID and a newer revision of the same PNID. The differences get highlighted within the system. So you don't have to keep searching for cloud markings, revision triangles, etc., to understand what are the changes that have happened. Rather, the system will do it for you. You can concentrate more on the key aspects of it rather than searching for what has been changed. We can also bring in work processes there. So you would want to define any workflows that are required. So we can have due days set. We can automatically or manually distribute the entire distribution matrix. So for example, a plot plan should be gone to all the disciplines in engineering. An equipment plan should go to all the disciplines in engineering. A process data sheet has to be flown from process team to the other disciplines. So those kind of details can be fixed within the system. An internal QA review can also be handled within the system. Any draft workflows that you would want to define it before you are pushing it for next major revisions can be handled within the system. All the project communications, all the transmittals that can be pushed across can be handled through the system itself. So this is a small example of how a review and markup is happening through the system here. So you can see an inbuilt toolbar and the dynamic stamps, also a comments panel that are there for the users. The bottom side, you can see there are markup layers. That is something that I wanted to touch upon. So if there are multiple reviewers working on the same document, collating all those comments from various people would have been a little difficult task if you're working in a siloed environment. But with SDX, you'll be able to ask multiple people to review the same document, reduce the time taken for the document workflows, and then further push it down for the IFC or during the maintenance phase to take these correct decisions at the correct time. Not just that, we also have two-way integrations with the other pieces of Hexagon for operations management. It's J5. We have project controls called Ecosys. We can have this integrated with the commissioning softwares called Smart Completions, where you take a digital handover from your EPCs to the owner-operators smoothly through using technology rather than having the physical files being sent out bringing in those big decks or the folders, and then it is getting placed in your office. We also have integrations with Hexagon EAM, that's the asset management piece, what Samir was talking about a little bit earlier. We can bring in all the data sheets, the 3D models that you would want to view in. Then there are standard connectors for the maintenance management, the historians, the laser scans that you would want to look at it. And also there is now an integration with Cenosco, where we will talk about that in a while. So this is a small understanding of how a quality assurance would happen. So your subcontractor is loading all the documents in SDX, the metadata and the drawings based on the rules that we have defined, the naming conventions as small as it is, that is being properly checked before it gets pushed into the system. Using the distribution matrix, it is gone to the respective disciplines to have their reviews. You can have a consolidator who would consolidate all the reviews that are happening at various places from various disciplines, send it back to the contractor to do the required or the necessary changes there. Same thing can also be achieved with project communication along with the technical queries that you would want to ask your licensors or your EPCs in that matter. And then again, review those responses back and then send it back to the required personnel. This is a small understanding of how Hexagon SDX looks like. So we have searched for a tag, a vessel tag, a suction scrubber here, and we are looking at all the details of that particular vessel on the screen. We can also look at the procurement details of it. We can understand whatever the concurrent engineering that is happening, so keeping your digital twin evergreen. Now that we have seen it inside, so we would want to look at where is this placed inside the 3D model without opening a 3D modeling software. So it gets hotspotted to the correct location where this equipment is located in your plant or in your offshore platforms. And it's not just highlighting the equipment alone, but it is also hotspotting it and gives you visual intelligence reports. So if you would want to understand the safety critical equipments that you would want to look at, so you can visually highlight them based on your requirements. So here I've highlighted all the approved equipments that we are looking at. They are all highlighted in orange, and then there is an yellow equipment in the background that says it is still in progress. So you can understand where we would have to take the decisions in a timely manner. Not just that, you can also navigate to different other objects, or for example, a valve here. So I have selected a valve within the 3D, and then it is telling me that this is a shutdown valve. This is located in this location. The parent object is that particular vessel. And if you would want to then go ahead and see it in the actual site, so if it is a brownfield plant and you already have the plant up and running, so you can also view the actual site conditions through the laser scanning model that is also integrated within the system. Once we have seen the 3D, now we would want to understand what's the 2D or the PNID for this. So again, there's no searching here. It is already interlinked. It is contextualized. So it opens the correct PNID, hotspots it to the correct equipment that we are looking for, and gives you the details related to that. So once we are done with this, now we would want to also look at what's the sensor data that is there for all the pressure transmitters that have been sat on this particular equipment. So we would definitely move from this particular tag to that particular element that is placed on the equipment. So I'm just opening an LCV walls sensor data, the OSI Pi historian data that I've pulled in. So it's an 8 hour or a day or a week or a month, how we would want to visualize it if there are any anomalies that can be captured right here, and then go ahead and perform those or take those necessary actions that are required. Not just that, if you're raising any work permits to go ahead, get these things solved, that can get integrated inside this. So this is a work permit that we have defined to fix a pump and isolate the system before we can do a certain maintenance activity. So the entire details are also being pushed upon that particular vessel tag that we started searching at the beginning of the video. Last but not the least, if we are looking at any change request or any MOCs during the operations or during the maintenance phase, we can define a particular workflow that states that this has to go and sit with this particular integrity engineer, this particular maintenance engineer. He gets an email notification. You don't have to manually write an email to him. The system does all those heavy lifting for you. And then it is going to help you a lot in taking timely decisions in a timely manner. Well, that being said, let's understand how Hexagon SDX and Cenosco together can help you with asset integrity and the IMS suite of solutions that Cenosco offers. Before understanding that, we will also look at the technical assurance and cost optimization loop, which is very fundamental for us. So find the foundational elements, the criticality of the equipment, the inventory of the equipment, the work activity, which will help in risk-based care plans rather than time-based. These tasks are to be defined keeping risk and cost optimizations at the top to help equipment lifecycle performance. So there's a global library templates that are predefined, available inside the IMS, and then you'll be able to use them here. Once the plan is done, then we take up a strategy towards it. How do we handle this particular anomaly? So that's where the integration of tasks from various solutions from the IMS suite of solutions, may it be an SIS, that is Safety Instrument Systems, or from RCMs, integrate them together and then define your scope of work, which gets optimized because of the technology, and then finish that within the agreed time frame. Once we have done with that, once the execution is completed, then we can definitely have learn and improve. So if there are any lesson learned that we would want to have it, that can be reviewed upon, pushed it for the upcoming activities. So any high-risk assets, we would recommend the use of Cenosco there. May it be oil and gas, may it be petchem, may it be chemical industries, or paper and pulp, or even process industries. Cenosco is the place which will help you with the integrity management. What's the current scope or the current handshake between Cenosco and Hexagon? Is basically Hexagon SDX that we saw earlier, along with the enterprise asset management, that is Hexagon's EAM at the center, having the digital twin, having the engineering data and the operating data here, bringing in the suite of solutions that IMS Cenosco offers, upgrading the maintenance strategy from being reactive to being predictive, gaining insights into the equipment performance with accuracy, an inbuilt inspection management system, so you know that the operators are never going to miss another inspection in their lives. To name a few, like PI stands for the equipment integrity, when and what to be inspected or repaired using the RBI and the advanced corrosion calculations, for example, what Rowan was mentioning a little earlier. We will go through this with a typical use case on how the asset integrity management puts in place, helps you saving time and taking decisions. How did we solve a problem until today? Finding the extent of degradation of your current systems. A field inspector reports an anomaly. Here we have written it as Word doc. Probably we have seen a piece of paper flowing around from one location to another location as well, right? So that becomes a much more difficult task than having it in a Word format. That is then sent to the integrity engineer who reads that report. Based on his availability, he'll take a decision of when do we go and attack this particular problem. Once he does that, he goes into the maintenance system to search and review the maintenance records and other specifications related to that equipment of that particular anomaly. An user, again here, understands to what design extent was this particular equipment built. So that means he has to look at certain data sheets, certain PNIDs, which are probably submitted by an EPC guy, but was never updated during the O&M phase. So there is, again, a siloed system there, not so up-to-date drawings available with you. So what he does is he goes and sits with the process engineer to understand, boss, please tell me, is there anything that has changed with this particular asset during the O&M phase? If he says yes, then that's the new information that he gets, and which, again, has to be passed on to the integrity engineer. The inspection engineer here again searches for the relevant tags manually, maybe in an Excel file, maybe in a CMMS, or he even checks about the alarm and the event data that is there for this particular equipment or that particular sensor. Having done with everything, the corrosion engineering, the corrosion engineer then finds the relevant data again through an Excel file or through a siloed system. Capturing all these information, the integrity engineer then has to sit with 12, 13, or 14 different documents at different locations and then take a decision whether to have furthermore inspections or maintenance of this particular equipment. It's a long and a cumbersome process, right? Multiple systems, more siloed approach. The records are out of context. So at the end of the day, you are spending more time in finding the data rather than finding a solution to the problem. So that's something which we would want you to move away from and start working on the problem where data is readily available to you at any given point in time. So how does SDX and IMS gives you this solution here? So IMS provides an insight into the risk and priority of each tag based on our understandings there. The inspector, once he detects the anomaly, using a dynamic checklist that is there in the IMS, it gets automatically correlated with the corrosion loops and barrier management for the initial assessment. Then the integrity engineer goes into SDX. This is where SDX gives you that multiple data sources being viewed on one single screen. So where you would be able to understand or analyze the multiple data sources, identify the areas of concerns. Data is correlated with 3D model as well, so you can be able to visualize it in the 3D as well, and then make data-driven decisions on additional maintenance or inspection aspects. Once this is done, the IMS automatically gets updated, allowing integrity engineers to further plan the inspection and the maintenance activities. So again, multiple different systems, but all integrated with each other, giving you the data handy at any given point in time, well connected, well contextualized. Here, you are spending your time on solving the problem, taking timely decisions so that you don't go into a shutdown, but the plant is still running and the maintenance is completed. To summarize it, I'm bringing back the same slide that we had shown earlier. So the digital backbone, that's SDX, and Cenosco together gives you that visualization and personalization for taking timely decisions, for faster decisions, and keeping in mind the 4 pillars: safety, efficiency, quality, and productivity at the base of it. Thank you.
Requested to be there on stage. If any questions are there, anyone can ask.
Sir, I can't see you. Oh, okay.
Yeah, actually, I'm Dr. Parvatalu from ONGC Energy Center. Just I would like to ask about this thing. It's a very nice presentation, actually giving overview of what are the activities between Hexagon and Cenosco. But the question is that where all you are implementing these kind of things, like actually practical example of the systems actually where you are working with right now.
So in India, we are working with a couple of owner-operators currently, where SDX is getting implemented. A specific use case in the combination of Hexagon SDX and Cenosco, I'll get that information and I'll share it across. But SDX is being implemented quite widely within India. Not the rest of the global is still there. But we have certain use cases within India. One of the names that I can talk about is we have Reliance, who is working for it, who has SDX. We have implemented in Adani, probably Mr. Vinayak Karche sir, jab aayenge to he'll help you out with that. He is spearheading that particular project. And yes, globally we have multiple different customers.
Okay, that's one thing. And second thing is that while implementing these kind of solutions, actually future technologies and all the things, incorporating that, you would be collecting fresh data for analyzing the things like, or whatever that existing data is there, actually just you'll be taking a look at it and then you'll be finding your solutions like.
So both ways are possible. Existing data, I mean, we wouldn't want you to change the way you are already working. So we would want to complement it rather than asking you to change entirely, like what Rowan was saying. It's not a big bang thing that we come in, we change everything. The cultural difference, the cultural adaptability will be a tough choice there. So having said that, back in 1986 also the refineries were built. For example, if I can take, today also they are being built. So the technology has helped them in building them faster. So the existing assets that you have, probably majority of them will be in paper drawings that we have. So we can help you in digitizing them one way or the other. If the 3D model is not available, then the one that I showed you, that we will have to laser scan it, then bring it back, give life to it inside the 3D, then make a digital twin going on further. Any new or revamps that are coming in, I know most of you already ask for a 3D model from your EPCs or subcontractors. So we can use that data, integrate it within the system, and give you those insights. Both ways.
Yeah, actually, one last question, actually, if you allow. Actually, what I wanted to ask you that, because Hexagon has been doing a lot of work in these hydrogen areas and all, actually, when we are coming up with some solutions for the future energy transitions and all.
Right, sir.
So what way that this entire thing can be integrated with the existing systems, actually, when aging oil fields and all, when you are doing it, pipeline transportation, hydrogen mix and all things are coming up with the kind of approach that we are going to do for asset integrity studies and all things like.
Yeah, we can look into it a little deeper and discuss it in person. Maybe
Okay,
Rahul can also join in.
Yeah, okay.
Yeah.
Thank you.
Sure, thank you.